Hi there, and welcome back to the channel. I'm the GCSE science teacher, and in today's lesson, we'll be learning about ionic bonding. This is for a brand new topic here on my channel for chemistry GCSE. It's topic 2 bonding. I've already done topic 1, and there is a playlist on my channel which I'll leave at the end of the video for you. If you do want to learn more about chemistry, biology, and physics at GCSE, feel free to like, comment, and subscribe, and share this with anyone else you think would benefit from learning more. You can also check out my Instagram and TikTok at the GCSE science teacher for more revision resources. So the question of the day is, what is the charge of a cation? Well, it's positively charged, or it's positively charged. And this essentially just means it's an atom that has lost an electron or donated one and now has a stable outer electron shell but has a positive charge because it's donated that electron. And these are often metals that we're talking about. So when a metal atom actually reacts with a non-metal, those electrons are transferred from the metal to the non-metal. And we end up, like I say, with a cation or a positively charged ion. And the non-metal, because it's gained that electron, it actually becomes negatively charged. And this therefore means it's an anion. So we're going to talk about this in terms of electron transfer, specifically dot and cross diagrams, which you may be asked to do in the exam. So we have a group 1 atom here, which is sodium, a alkali metal. We also have a halogen, a group 7 element, okay, a group 7 atom, and you can see that that's chlorine. Now what I've done here is I've written out the electron configuration for both of these atoms, and you can see that they are unstable at the moment. Sodium has 1 electron in its outer shell, a valence electron that it can donate. Chlorine has 7 electrons, or 7 valence electrons, in its outer shell. And notice, by the way, I have what we call dot and crosses to represent the electrons, and I'm only drawing out the valence electrons, those outer shell electrons, just because if we were to draw out everything, especially for bigger atoms like these, it can get quite messy and confusing quite quickly. So that's why scientists do that. So the sodium can donate 1 electron and become stable, and that chlorine can gain and accept that electron and become stable too. So if we react these two atoms together, we get 2 ions, and we have what we call ionic bonding. Because they are both attracted to each other, because they have oppositely charged charges, they actually have that an attraction together. So they form this ionic compound, such as sodium chloride or salt. And you can see that sodium now is positively charged. We have a positive in the top right corner, and we have the 2 brackets, which help us understand that this is now an ion, okay? The chlorine is the same. You can see that it's now got the dot representing the electron that's been transferred amongst the other crosses that are also the electrons of chlorine. And it's now forming a chloride ion. Okay, notice that sodium chloride is a salt. We've changed the name of it slightly, and that also indicates that it is an ion as well. And notice, because it is an ion, sodium chloride is actually used in things like electrolysis, which we will discover together in the future on my channel, and it's part of the curriculum. And the reason it can be used in electrolysis is because of those charges. It can actually transfer or support with electricity and conducting electricity because of the charges. So it's quite an important solution, especially when it is mixed with water as well. So, electron transfers of group 2 and group 6 elements. So, we have magnesium, which is a group 2 element, and it has 2 electrons in its outer shell, as you can imagine. And group 6, as the name would suggest, it also has 6 electrons in its outer shell, and this one is oxygen. Now, they can react together to form magnesium oxide, a compound like this. And notice, because both of them have been able to either gain or accept or donate 2 electrons, that means they now have a 2 charge, or 2 plus charge for magnesium and a 2 minus charge for oxygen specifically. Also be aware that you could get asked about either version. So the previous one where we looked at sodium chloride, that was the ionic bonding between a group 1 and a group 7 atom, and this is now group 2 and group 6. These are the 2 versions of ionic compounds or ionic bonding that you could get asked at GCSE. So just be aware of that, okay? You want to make sure that each time you draw your square brackets, and each time you draw your different charges. Just also be aware, in this case it is a 2 plus charge or a 2 minus charge. We don't want to write +2 or -2. It's just the way that scientists have done this over time. It's like a traditional way of doing it, so you want to make sure you conform to those rules. It's the same when you look at the sodium and chlorine atoms. We have a minus charge, we don't have a -1 or a 1 minus. It's kind of like when you do, um, when you have your equations and you're balancing them, instead of writing a 1 for something, you just leave it as is, and it's implied that there is a 1 already there. I can go into this a bit more if you want me to. Please let me know if you do. But hopefully that does make a bit of sense to you as well. So, just to check your own understanding, pause the video and spot the mistakes. This is a piece of work from a student and they have made a few mistakes. What do you notice? Okay, I'll leave that for you. You spot the mistakes, comment below. It'd be great to get a discussion going on in the comments below. Thank you so much for your time today. I've been the GCSE science teacher and you have been curious. It's been great to talk about this with you. I hope you enjoyed it. And if you did, feel free to like, comment, and subscribe. Like I say, you can find out more information on my channel, but also on my TikTok and Instagram as well, at the GCSE science teacher. Have a great day and I'll catch you in the next one. Bye.